Today I'll be showing you or proving, or maybe let's use the word derive here. I'll be deriving the formula that gives you the angle in between two vectors when you're giving the vectors themselves. So it would be, oh, this is not dot product. Let me rewrite this. Cos theta equals the magnitude of A times the magnitude of B, where A and B are vectors, A dot B on the numerator. So this is the formula I'm trying to derive. And let's say A is this vector, A1, A2, B is this vector, B1, B2. From the definition of a dot product, A dot B would be A1, B1 plus A2, B2. And the magnitude of A would be root dot product of A, so that would be root A1 squared plus A2 squared. And the magnitude of B would be root B1 squared plus B2 squared, or length. This denotes length. All right, so let's draw a graphical representation. So let's say this is A, this is B, this is the angle between them. Let's call it theta. All right, so we can use the law of cosines here. So the law of cosines is sorry about that. So let this be vector A, let this be vector B, let this length be A, let this length be B, and let this side be C. All right? So the law of cosines states that the magnitude of C squared equals A squared plus B squared minus 2 magnitude of A, magnitude of B, cos theta. So this is the law of cosines. All right? And something you should notice here is that the magnitude of C just equals the magnitude of A minus B, or B minus A. And hopefully this should come as intuitive for you, because let's say you go to B, then to get to A, you have to subtract B and plus A, which would correspond to this. So you go here. And let's say you're at A, to get to B, you have to go through vector C. So to go through vector C, you need to minus A and then plus B. Does that make sense? I'll go to it again. So let's say you're on vector B. To get to A, you must pass through C. Now, to get through A, you need to be subtracted by vector B and added by vector A. So that would correspond to this. So here, you go here. And if you start on vector A, to get to B, you must go through C. But also to get to B, you must be subtracted by A and add by B. So from A minus A, 0, plus B, you go here. So C would equal A minus B and equal B minus A. All right? So we have this formula. We can choose anything we want. Let's just choose A minus B. A minus B squared equals the length of A squared plus the length of B squared minus 2A B cos theta. Okay? And you should know your, what do you call it? Your, hold on, let's just say there's some length D. Length D squared just equals the dot product of D. So if D equals this vector, and length of D equals root D1 squared plus D2 squared, then D squared would equal D1 squared plus D2 squared. And guess what? That's also the dot product of D times D. So we can just convert this to dot product form. Oh, sorry about that. Yeah, here's what it looks like. So we're going to convert this to dot product form. We get that A minus, we don't need to deal with the absolute value or magnitude sign here. A minus B dot A minus B equals A dot A plus B dot B minus 2A B cos theta. And now I'm not going to talk because my father is walking up, so hopefully you can understand this without my commentary. Alright, so this is a property of multiplying dot product. So A dot A, B dot B, the negatives cancel out, and then you sum B dot A and A dot B, because A dot B equals B dot A, which is pretty easy to prove. So you sum them together, you get negative 2A dot B equals whatever we have in this. A dot B and B dot B cancel out with A dot B and B dot B, so we get this. Negative 2A dot B equals cos theta. And hence, if you rearrange, you get this. Cos theta equals A dot B. And yeah, that's the proof. It's pretty simple. You just need to know your definitions well and the law of cosines. Thank you.